Yes, we are moving on to a different type of video, and we want to practically implement what we have learned using the computer and Python. Yes, we have always calculated everything by hand so far, which is obviously not suitable for practical use, especially since we might be dealing with very large data sets. Therefore, I thought it would be helpful to see how to work with Python in practice, for example, so that we can work with it. And for that, we will take a look at the notebook I have prepared here and go through it step by step. So it's about the data set related to the Titanic, no? Which you might be familiar with. It is very well known from 2001. And indeed, a lot is used very well in the data science field. And it's about this. We take a look at it here, so we are primarily working with pandas. And we have a CSV file that we will load from the internet. I'll do that briefly here. And with head, view the first 5 entries. And it is about the following. Each row corresponds to a passenger. And what you see here is that at the end, you can see whether someone survived or not, which is the most important information. Then there are other important metrics or features about the passenger, such as the class in which the person was, the name, gender, age, how many siblings were there, how many parents or children were there, how much was paid, what type of cabin, and where the person boarded, meaning where they first got on. And yes, now we somehow have this data. And what we can do now is take a look at the describe method, which already contains a lot of what we learned in 2021. You can see from all the numerical features, such as the count, which indicates the absolute frequency. In this case, how often this value was set, or how many times the value exists. This is different from the absolute frequency, which tells us how many times this value has been assigned. In most cases, that is 891 times. But sometimes the age was probably not known, and that's why it appears only 714 times here. Then you see the mean, the arithmetic average of the individual values, followed by the standard deviation, the minimum, which is the smallest value, and then you see the quantiles, which we also covered in the lecture, and then the maximum. We could take the age out here, which we can understand fairly well. So the arithmetic mean is approximately 30, the standard deviation is 14, and the minimum value is 0.42. For example, we also see that the median is 28, and the 75th percentile is 30, meaning that 75% of the people are under 30. And the oldest passenger is 80. This example illustrates quite well that it makes roughly sense. One could take another look to see if, since the minimum is 0.42, it is specified as a decimal, or rather as an integer. Yes, and we could go through everything here. That would be the classic case of exploratory statistics. However, we want to do something else now. We want to process the data a bit more so that we can handle it even better. And for that, one important thing is to look at how many values are missing. That is, where nothing has been entered. And we can take a look at this with is null. And here we see, as we suspected before, that the age is often not provided. And Kevin is almost never mentioned. Then we also have situations where we have qualitative features such as gender. Here we simply write male or female, so we don't have any reasonable metrics because we can only do that with quantitative data. Therefore, we will perform a transformation. It is often the case that we convert male to 0 and female to 1. And so we have quantitative features. Again, and now we take a step further and want to conduct a data analysis. We will use Matplotlib and Seaborn for this, and I want to show you various things here. Here we have various count plots where we look at the absolute frequency. And we have that, for example, with survived and not survived. So not survived is therefore you send. Oh no, sorry. So here we have the breakdown of genders. So 0 was, let's check again, 0 was male, 1 was female. And then we can further break this down here, who survived and who did not survive. And there we see at first that there are more men than women. Among the many men we see, the number who did not survive is significantly higher than those who did survive. So relatively speaking, most men die and most women survive. This can be seen here and makes sense again, because we all know the rule women and children first. So the survival rate of women was significantly higher. We can also take another look at which class survived and how the classes are divided. So first class is somehow the best, then comes second, and then comes third. And then we see that most people, of course, traveled in third class. Here, the bars are the largest. Then we still divide the classes into those who did not survive and those who did survive. And so we see that in first class. This is relatively understandable, as most of them survive. First class was given preferential treatment, while in third class, most of them died. Then let's take another look at age, specifically the age distribution of those who survived, which we have here in green. There we see that there are many who survived, many small children. And then we see among the survivors, there are mostly middle-aged individuals, which is also the mean and the median. And there we see, so to speak, a relatively normal distribution, just like we see with the non-survivors. Here we also notice a peak at the 30th. There is a small difference between those who survived and those who did not among the very old, as more of them tend to survive. Interestingly, those over a certain age are exactly the ones who no longer fit into this category of being very old, and they mostly die as well. But everything is also relatively logical to understand. The next step is now the correlation analysis. So we want to visualize the correlation visually, and there is a lot to see, which we will take a look at shortly. Specifically, we need to remove the quantitative, non-quantitative, and non-numeric values from our data set. Once we have done that, we can take a look at how the relationships are. And I would like to go through a few things with you. Let me make it a bit smaller. 2001. So we first see that it is represented here quite nicely. Red indicates a positive correlation and blue indicates a negative correlation. And then we can take a look at survive, which is our interesting variable. And then we go through this here. We can see, of course, that it is correlated with itself. That's always the case. That's this diagonal here. And then we see, for example, a very strong negative correlation in 2001, and that is the class. And now let's take a look or consider whether this makes sense. This means that survived is 1, which is greater than not survived, which would be 0. And if the value is 1, then the class is rather small. This means that if I survive, a class of 1 is rather small. That would also be more of a 1. This means that a lower class naturally implies that class 1 is better than class 2. More people survive in first class than in second and third class, so it makes sense. Let's take a closer look. Here, 0 represents male and 1 represents female. So this is a strong positive correlation. This means that if there is 0 on one side, there must also be 0 on the other side. 0 is death, and on the other side is 0 man. So death and man often come together, and 1 would be survival and woman. So we also see a positive correlation here. And then maybe we look at this as well. It is also positive, fair, and survived. So I am more likely to survive if I paid a lot. That makes sense, of course, because fairness is also related to class. The more I pay, the lower the class. This may also be a spurious correlation, or rather what is meant by a spurious correlation, but above all, this connection can be seen here. And I think that's why it's clear that there must be a connection to survived. And then being a child is a positive thing, although not entirely so, not that significant. But still, if someone is a child, then I am more likely to survive. Now we could look at various other correlations. We already have this one here, which is certainly noticeable. What else do we have here? Age and eye shield. It's also clear that these are correlated, as it has been directly calculated from that. Exactly. Yes. And this way they get a very good representation of the relationships within the data in a very compact manner. And now one could go a bit further. One could, so to speak, conduct individual regressions if one wanted to. You can take a look at that as well. But I would say it's not quite as relevant as this correlation analysis. And in summary, what have we learned about this data set? Women and children definitely have a higher chance of survival. The lower the class, the higher the chance of survival. And that age plays a significant role as well. So you have seen an example of how you can actually use the things we have learned so far, especially the correlation. Feel free to play around with the notebook. It is available via the link. And that was the end of the second week. Topic: correlation, regression, and data analysis. Next week, we will look at the topic of probability and learn the axioms for the first time, as well as how to calculate probabilities. Until then, take care, use, and